Okay, everyone, I want to do one more thing here. I want to show you just how ridiculous a set of nested if functions can be. For example, let's say we have a bunch of students here and we have their scores at the end of the term or whatever, and what we want to do is we want to compute their grade based on these series of conditions. If they get less than 60, if their score is less than 60, they get an F. If it's between 60 and 70, we give them a D, 70 and 80 C, 80 and 90, or greater than or equal to 90, they get an A. Okay? Now, that's actually going to be a lot of nested if functions inside each other. Well, let me just show it to you. Let me actually, I got it right over here. It displays an F here because it's in the wrong place. The cell it's evaluating is the wrong one. So I will copy this function and paste it right here. There, that's an A. Okay, why did that work? Well, it turns out that even if you copy formulas from one area of the sheet to each other, the formulas, the cell references will change. Here, for example, it's referencing G3. What's in G3? There's nothing there, okay? But if I copy it over here, it says B3, which is this score over here. See, actually when I created, I made it over here, then I copied it over here and deleted it here, so I wouldn't have to type the whole thing out for this demo again, but I just copied it in here. Now I'm going to pull it down, and there we go. Now how does it read? If B3 is less than 60, what does that mean? Well, that's definitely an F. Otherwise, after this comma here, what would it be? Well, it could be anything. D, C, B, or A. Okay, well, alright. Then the next thing we test is we have a nested if function in here. Well, if B3 is less than 70, it's a D. Now, why didn't I have to say it was greater than or equal to 60 like it says over here? Well, because I already made that test. If B3 is less than 60, the only way I could get in here is if this condition was false. That is, it must be greater than or equal to 60, right? That's the only way I could get into this area of the if function. The F is the value if true, it's less than 60. If I got here, if, it means that this condition, B3 less than 60, must have evaluated to false. Therefore, B3 must be greater than or equal to 60. So if I were to put that in here, it would simply be redundant. Okay? That's the only way I could get here, is if B3 were greater than or equal to 60. So I only have to test if it's less than 70. If it is, give it a D. If it's not, well, it could be A, B, or C. So I come in here again, and for the same reason as I did before, I only have to test that if B3 is less than 80. I don't have to test if it's greater than or equal to 70. It is, because that's the only way I could have got this far into the nested if functions. Anyway, if it is less than 80, C. Otherwise, if it's less than 90, give it a B. And the final alternative is, if it's not less than 90, the only thing left is A. Now, that's pretty nice, but take it from me, typing out all these nested if statements is not fun to do. So I hope you don't find yourself in a situation where you might have logic that's that complicated, but it might happen. Okay, so I think that winds up, concludes our discussion of the if statement. We're going to look at something similar to that now called a lookup table. I'll see you in the next video.